Welcome to our lesson on box and whisker plots. So a box and whisker plot is a method for graphically depicting groups of data through their quartiles. How do we construct a box and whisker plot? Well, first step is we order the data in ascending order of magnitude. Then we determine the median, lower quartile, and upper quartile. We proceed to draw a number line to accommodate all the values in the data set. Then we draw a rectangle above the number from the lower quartile up to the upper quartile. Then we draw a vertical line at the median inside the rectangle. And lastly, we draw horizontal lines known as whiskers from the box to the lowest and highest data values respectively. So let's get into an example. Let's say at a plant nursery, the height of 13 seedlings in a box are measured in centimeters and recorded. We are to construct a simple box and whisker plot. So the first thing we do is we put the numbers in order. So we have 5, 6, 8, 9, all the way up to 20. Then we have to determine the median, the lower quartile, and the upper quartile. So first, the median. It is going to be 12 because there are 13 numbers here. So if we take 13 and we divide it into two equal pieces, the number right in the middle will be the 7th number, which is this number right here, that 12. The lower quartile then will be when we take that bottom 6 and we divide those into two equal pieces. So if you take 6 and divide into two equal amounts, it will be 3 and 3. So the lower quartile is right in between the third and the fourth number, right in between 8 and 9. So what number is right in between 8 and 9? Well, that is 8.5. Similarly, the upper quartile, we look at the top half of the numbers. And so the same thing applies. There are 6 of them, so we divide it into two equal amounts, 3 and 3. So the upper quartile is right in between that 14 and that 14. But of course, the number between 14 and 14 is just 14. So when we construct our box and whisker plot, we will draw our rectangle from the lower quartile, which is 8.5, up to the upper quartile, which is 14. That's our rectangle. And then right at the median, which is Q2, that's where we draw a vertical line to show that that's the median. And then our whiskers on the two sides go from 8.5 all the way down to the lowest value, which was 5, and from 14 all the way to the highest value, which was 20. Seems easy, doesn't it? Let's get into another example. The box and whisker plot shows the scores of two classes on the same test. Which class did better? Well, if we look at it and we analyze what we see here, then we can see that comparatively, the first period class on this test, their lowest was 60 marks and their highest was 98 marks. The second period class, their lowest was 72 and their highest was 95. What else can we compare? Well, let's get into some percentages. We can say that 50% of the first period class scored between 60 and 80 points, right? From the lowest value up to the median for the first period class, which is at 80, 50% of them scored between 60 and 80. Meanwhile, for the second period class, 50% of the class scored between 70 and 85. So if we look at the bottom half of the class, the bottom half of the first period class, they went from 60 up to 80. Meanwhile, the bottom half of the second period class, they went from 70 up to 85. That's their range. If we look at it, we can safely say that the second period class did better as a whole group, right? They acted more homogeneously, as we would say, right? As a group, they were more cohesive. The first period class didn't have somebody who scored better than everybody else in the second period class, but they also had much more that scored way less than even the worst person in the second period class. Therefore, the second period class did better as a group. What are some advantages of the box and whisker plots? Well, one, the box and whisker plots are ideal for displaying the median, interquartile range, and hence the variability of a distribution. They are especially useful for indicating whether a distribution is symmetrical or skewed. Are the scores evenly distributed or are they skewed towards one end or the other? Like for example, with our previous example there, we could say maybe this class had more persons towards the lower end of the numbers, hence more people did poorly, things like that. They can accommodate distributions that have a large number of observations, whereas stem and leaf diagrams cannot. They can readily show if there are potential outliers in the data set. Was there somebody who scored really low, right, and all the rest scored rather high? Or was there somebody who scored really high while everybody else scored pretty much low? Things like that. They are useful for comparing multiple sets of data because they can use the same number line for multiple sets of data, just as we saw in our previous example. Some disadvantages: it does not show every value in a distribution as a stem and leaf plot does. The raw data is not obtainable from a box and whisker plot. And with that, we come to the end of this lesson. See you in class.